Assalamu alaikum. Bismillahirrahmanirrahim. In last day, we have started fundamentals of BGP and discussed some slide. So I continue from the beginning. Okay, just review last classes and adding some new slides. Okay. So fundamentals of BGP. BGP is it's a you can say it's a dynamic routing protocol. You can say it's a path vector routing protocol. Only routing protocol which is used in internet communication. Okay. So BGP is border gateway protocol, and the uh, BGP actually two types. So one type is eBGP, external BGP, and another one is iBGP. That means internal BGP. If you if you want to deploy BGP in your network, in your own organization under a single ASN, you have to consider iBGP. And if you want to communicate from one AS to another AS, it can be one organization to another organization. You have to configure eBGP. That means external BGP. So if you configure in same AS, that will be iBGP. If you configure BGP in different AS, that will be eBGP. So I will cover more details in later slides. So what is BGP? So number one, what is BGP? BGP is the core routing protocol within the internet. Actually, if you consider all over the internet, you see multiple AS is connected with each other. See here, multiple AS is connected with each other. If you see the whole internet. Okay, so in that case, you can say BGP is a path vector routing protocol. Basically, it's used for inter-domain routing. Okay, and through BGP, we can communicate from one network to another network. That should be in public network, or that should be in public IP addresses, not private IP addresses. If you consider the internet, okay, but in your organization, it can be private IP address, private ASM. Okay. This is the all-over view, which views the internet as a collection of autonomous system. Basically, autonomous system means which is run by a administrator, which means a single organization. You can say one service provider. You can say it's a transit provider. You can say it's a organization or institute. Okay. So another statement is BGP is more scalable and offers a greater amount of control through policy than a interrogator protocol. BGP basically there have multiple attributes in BGP, okay, but in IGP there is no multiple attribute. Okay, so maybe if you see the IGP like WSPF and ISIS, only single metric. Only single attribute is available there. You can mention if you have multiple path to send packet, one source to destination, you have to utilize one path. Other path will be underutilized or unutilized. That is the difficulties or and that is the limitation of ICP. But in BGP, there is multiple option, multiple attribute there. Okay, so that can be happened based on prefixes. If you advertise prefix considering IPv4, that should be minimum /24, and for IPv6 /48. That is the minimum. So you can take traffic based on prefixes. You can say it's user upload traffic. It's a internet interruption. Yeah. Record is running. Okay. So we are here. What is BGP? That is part one. That is the BGP statement is it's more scalable and offers greater amount of control because of attribute. Okay. So and another part, you can say BGP is a set of routers and that, sorry, AS is a set of routers that operate under the same administration. This is the definition of AS. What is AS? Autonomous System Number or Autonomous System. Autonomous System means you can say it's a one organization, or you can say it can be any organization. It can be ISP, it can be a financial organization, it can be transit provider, internet transit provider. Okay, and some administrator operate this AS, and multiple router will be in AS. It can be a single router or it can be multiple router. It's basically depends on the network topology or network size. Okay. So another point is BGP uses the routing information to maintain an information base of network layer visibility information. Basically, BGP by default they communicate based on IPv4 unicast. You can enable IPv6 unicast. You can enable multi-protocol BGP. Okay, like when you configure MPLS, if you configure MPLS L3 VPN, so that will be you have to enable VPN v4 address family, or VPN v4 in LRI, or VPN v6 and LRI. Okay, so that is multiple option in BGP. Okay, so another point is classless routing protocol, what supports prefix routing. I already discussed about that. Okay, based on prefix, BGP maintain the upload and download traffic, or BGP manipulate upload and download traffic, user upload and download traffic. Okay. When should you use BGP? BGP you should use when one service provider is connected with another service provider. You can consider BGP. If one customer is connected as a multi-home, that means one customer is connected with different service provider, two or more than two. You have to maintain BGP. That will be scalable, but you can configure static routing, but it will be difficult to maintain. Okay, in that case, BGP is preferred, and you should use BGP there. Okay, but one customer have single link, single connection, they are connect with single service provider. Okay, you can say it's a single home. You can configure here is static routing, but BGP, if you configure here BGP, that will be, I think you can get some advantages. If you change anything in your service provider network, so automatically every customer will get the update. No need to statically maintain any customer. Okay, so in that case, I think single connection, single service provider, but you should maintain BGP. That will be scalable, or that will be, I think you will get advantage. Okay, so when should you use BGP? That is part two. BGP is typically used in large enterprise environments or multiple ISP connection exist. I already discussed about that. And another option is portable IP ranges. But here, portable IP ranges means you just consider here you have public ASN, and under public ASN you have public IP addresses there. Okay, so if you connect one single service provider, just you configure the BGP, advertise your prefix, service provider advertise the default or full route towards your network, towards your router. So you will communicate over the internet. You will communicate different destination. Okay. If you want to move one service provider to another service provider, just disconnect the link, disconnect the BGP, and just newly configure the BGP with new service provider and advertise your prefix, and you will get internet and other services. Okay, in that case, you can say it's a portable. Okay, so there is no dependency, but in static routing, there is some dependency. Okay. Does not mean private IP address. Portable means that should be in public IP addresses. I already discussed with you, service provider vendor. BGP loop avoidance. This is it's a 100% guaranteed protocol where no loop will create. Okay, so BGP is called loop free routing protocol. Loop free routing protocol. Okay, so here, basically, they maintain this mechanism, um, considering just when one is advertise their own IP prefixes to another is, they just not taking their own is IP prefixes through the another service provider. So this is the main mechanism of BGP to avoid loop. So pairs in different ways use the here you can two types of BGP here. One is external BGP, that means eBGP, and another one is internal BGP, iBGP. So pairs in different ways use the external session type, that will be eBGP, and pairs in the same ways use the internal session, that will be iBGP. Okay, so BGP have two types. One is eBGP, another is iBGP. BGP loop avoidance, just considering this, each S has at least one border gateway belonging that S. Consider here, this S is 64501, this S is 64503, and this S number is 64502. Loop avoidance mechanism in BGP. Number one, eBGP, that means AS path. Considering the AS path, eBGP external link direct connect, that is another one is TTL value. And another option for iBGP, that is logical full mesh. You can configure route reflector, BGP configuration, or you can configure manually full mesh. Okay, to avoid loop. So in that case, just consider here, you just advertise one prefixes from here. Your prefix can be 1.1.1.0/24. You advertise this prefix, all router guiding update, and advertise also here. And just you consider another connection from here. Okay. When advertising this prefix through this link, this router will not take this prefix because this prefix origin S is this one. This is not receive this prefix through another link. This is the main mechanism. Okay, for loop avoidance. So option BGP uses the loopback interfaces for stability region. We configure iBGP using router loopback interfaces because point to point iBGP have some limitations. iBGP have some limitations. One limitation is consider here. under 64502, there is multiple router. Okay. Consider this is a customer. Customer advertise one prefix here. This is ABGP and this is IBGP. So getting prefix from ABGP, those prefix will advertise automatically through IBGP. Okay. Then again, we configure here IBGP. So IBGP, after getting prefix through IBGP, this prefix will not advertise again in IBGP. Will not do this. So this is the limitation of IBGP. That means getting route or getting prefix through IBGP peering, this prefix will not again advertise towards the IBGP peer. That will be advertised in EBGP peer, but not advertised in IBGP peers. Okay. Okay. In that case, we configure IBGP peer using router loopback interfaces. So consider here, all router have self loopback interfaces. So I configure here loopback to loopback IBGP, loopback to loopback IBGP, loopback to loopback IBGP, loopback to loopback IBGP. That is full mesh. Okay, I receive prefix through EBGP, but then all router is connected with each other through IBGP, and BGP session is loopback to loopback. So EBGP then IBGP prefix will be permitted. In that case, there is no limitation. So this is the one solution of IBGP restriction, IBGP limitation. This is one solution, full mesh. Okay. So BGP loop avoidance. BGP uses the loopback interfaces for stability reasons. These interfaces are always alive unless the router dies. This is another reason. Okay. BGP transmission control protocol session is established using the routing tables, also known as the routing information base, also known as the routing table. Basically, BGP use the TCP session to communicate the BGP peering or BGP neighbor. Okay, there is two different option. One is TCP connectivity option and another option is BGP option. If TCP connectivity option established, then a router initiate the BGP connectivity for BGP sessions. Okay. BGP peering. This is first one is TCP connection. Okay. First one is TCP connection. So if you configure BGP between different AS, see here, router 1, AS number 64501, and another router here, router 2, and the AS number is 64502. There is different AS. So this BGP type is eBGP. If you configure BGP between different AS, this BGP speaker have to complete TCP connectivity and BGP connectivity. In TCP connectivity, there is 3 state, and in BGP connectivity, there is 3 state. Total 6 state. BGP speaker, that means BGP router, have to complete 6 state. Then you can advertise your prefix or you can receive prefix from a remote peer. Okay, so BGP peering sessions are manually defined. There is no automatic option here, no automatic neighbor discovery here. Okay, manually you have to configure BGP. Okay, relies on TCP connection. Its BGP basically depends on TCP connection. If TCP connectivity is okay, then initiate BGP connectivity. If TCP connectivity failed, so there is no option to initiate BGP connectivity. Okay. Next. See here, the various BGP neighbor state. We already see 6 state is here. Under TCP connectivity, there is 3 state. One is idle state, connect state, active state. And BGP connectivity options, there is 3 state. One is open state, other is open confirm, and last one is established. If your BGP neighbor is established, you can receive prefix from BGP speaker. You can advertise prefix to your neighbor BGP router. So in TCP connectivity, first state is idle. So what is happening in idle state? Okay, is the initial state. Is the initial state? Yes, this is the initial state. Start event is required for the local system to initialize BGP resources and prepare for transport connection with other BGP peer. Transport connection, that means TCP connection. Okay. So the ideal state, basically this is the initiation. You just configure the BGP in one BGP router, and then you configure your neighbor router, then they will initiate first initial state. You can say it's the initial state. And this prepare for TCP connection. In ideal state, they are trying to attempt a TCP connection. So from ideal state, and they will go to the connect state. So in connect state, there will be multiple functions here. So first one is waits for the transport protocol connection to be completed. They check TCP connection is okay or completed or not. Transport protocol connection succeed, local system. If TCP connections succeed, then send open message, then sends open message and transition to the open sent state. Okay, if there is a condition, okay, if transmission, if TCP completed, they will initiate, or BGP router will initiate open message, and this state will be the open sent state. If failed, if TCP connection failed, what happened? That will be going idle state. Okay. Transport protocol connection phase, local system, restart the connection try timer, listen for a connection initiated by the remote BGP peer, and changes its state to active. Sorry, changes its state to active. Idle to connect, then active, not connect to idle. And number 3 in TCP connectivity state, tries to acquire a peer by initiating transport protocol connection. Again, try to acquire TCP connection. If the connection succeed, send the open message and BGP speaker set the transition state is open sent. If the system remains in active state, check physical connectivity as well as the configuration in both peers. That means when we configure BGP, that can be configuration mismatch, that can be not getting P2P reachability. It can be anything. So you have to check physical and logical, both. So this is TCP connectivity section. In TCP connectivity section, there is there is 3 straight. So you have to complete TCP connectivity to initiate the BGP connectivity. Okay, so in open set under in BGP connectivity, in open set, router will do BGP waits for an open message. BGP waits for, that means TCP connectivity done. TCP connectivity done, succeed. So in that case, BGP router waits for an open message. When an open message is received, it is checked and verified to ensure no errors exist. When getting the open message, just checking everything is okay, then send the keep alive message. Okay. If the error is detected, if the error is detected in open set message, the system basically transition to in idle state. If no errors, BGP sends keep alive message. Keep alive message. Okay. And then send open confirm message. So in open confirm straight, waits for keep alive or notification message. Waits for keep alive or notification message. If no keep alive message is received, the system sends a notification message and changes to idle state. That means in open confirm, I'm a BGP speaker. I'm waiting for keep alive or notification message. If I get the keep alive message, then I then changes my state to establish. If not, if not receiving the keep alive message, so peer state transit to idle state. So this is the basically functions of a different state in BGP. And last one is establish. In established state, BGP exchange, that means take and give. Exchange update. In update message, they will send a different prefix and receive also different prefix. Also, also send a notification and keep alive message in established state. When updated or keep alive message is received, the system restarts the whole timer. Okay. If the negotiation hold timer reaches 0, the system sends out keep alive message and restart the hold timer. So here hold timer is basically this is the wait time. If anything happened or anything any error or physical link downs, anything happened in network in BGP session, they immediately just close the neighbor or down the neighbor. That is not accurate. The router wait for sometimes. Okay, this is called the hold time. So Juniper normally use 90 seconds as a hold time, but in Cisco and other vendors like Cisco, MikroTik, they use 180 seconds as a hold time, BGP hold time. This is the total picture, TCP and BGP connectivity. This is the total picture. When one BGP neighbor is communicating with other BGP neighbor, there is multiple state, idle, connect, active, open set, open confirm, and establish. So this is the full picture. We already discussed this. Okay. So there is multiple messages communicating between BGP neighbor, and the message type basically 5 message types. One message open message. When open message sent, when open message sent, if TCP connectivity succeed, if TCP connectivity succeed, then BGP speaker send the open message. And another BGP speaker receive the open message and send the keep alive message to another neighbor. Okay. So in open message, sent once the TCP/3 handshake is completed. That means TCP succeed, then open message initiate to BGP neighbor. Initiate the BGP session, content details about the BGP neighbor and information about supported and negotiated options. So open message when router throw the open message, when TCP connectivity succeed. This is the open message. Number 2, update message. Basically, in update message, they send the route update and others route specific attribute. Okay, and keep alive message. It's a basically recurrent message. It's basically recurrent message. BGP speaker continuously send keep alive message, and neighbor BGP speaker receives this keep alive message and send the keep alive message to checking my BGP neighbor is die or not. Okay, so keep alive message does not use keep alive at the transport layer. Instead, peers exchange keep alive as often as needed to ensure that the hold timer does not expire. And number 4 is notification message. Basically, if any wrong in BGP session, it can be happened due to misconfiguration, or it can be happened due to multiple interruption of BGP peer. Okay, so in that case, BGP will send the notification message. That means if any error detect, then notification message will be sent. And last one is refresh message. Sometimes you configure the BGP, but you will not get the route update. BGP established, but you will not get the route update. They wait for whole time, 180 second or 90 second. For Juniper, it will be 90 second. After 90 second, you will get the route update. So in that case, you can refresh your BGP session. It can be soft, it can be hard. If you stop clearing the BGP session, you will get quickly, you will get prefix quickly. This is the refreshness. So for refresh, what is the reason of refresh? This is the reason. Basically, routes are only added and withdraw because there is no timer and automatic refresh present with IGP. Refresh message type has this capability. Okay. If some route is coming, the refresh message will just synchronize this route in the BGP speaker and the neighbor BGP speaker. So there is basically the BGP message type. There is 5 BGP message types. Keep alive message, update message. There's the details. Okay. A high level BGP operation. See here, multiple service provider is connected with each other. Static default route ISPA. It's a customer sending. There is no BGP here, so it's a static route between customer and service provider. And it's a customer B. There is configured the BGP. So the limitation is for static route customer A. Send the static route towards the customer A. You have to maintain in service provider, also in customer side. Okay. So customer A is single home to ISPA, which is the this subnet, which was assigned by ISPA. That because customer A have no own AS number, have no own public IP addresses. In that case, and customer A have only single connected with single service provider. In that case, service provider just lays their public IP addresses to use in customer in. So in that case, service provider have to maintain the static route towards the customer A. Also, customer A also maintain the static route. So it's the case study basically. Customer A, static route, just considering here is static route and BGP. Okay, so every option we recommend the BGP. Your customer have no IP addresses. That means have no public ASN and public IP addresses. So keep the private ASN, and you configure the BGP with that customer. You give public IP addresses from your service provider. That will more dynamic compared to static routing. Okay. Aggregate prefix externally. This is some options. Default is static route. If down, so static route is here. Customer down, but static route will be here. Those prefix will advertise to another service provider. And when customer be sending packet to customer A, this packet is coming in SPA. But in BGP, if customer A down, BGP will not announce customer A prefix towards other service provider. So this packet will be dropped immediately. That will be another advantage of BGP and static routing. Okay. Constro SPP, BGP attributes. Okay. Now we discuss BGP attribute. Basically, BGP attribute is the main topic in BGP. If you know BGP attribute, every attribute, then you can manipulate your customer traffic. You can manipulate your upstream traffic. That is very easy. But you don't know BGP attribute, you will not do manipulate any prefixes or any routes or traffic. Okay, so there is multiple attribute here, and the attribute have some types. Okay, attribute have some types. Number one is well-known mandatory. Well-known mandatory. This is the BGP attribute type. And in well-known mandatory, there is three attributes here. Three attribute is well-known mandatory. S path, origin, next hop. So what is well-known mandatory? What is well-known mandatory? Well-known mandatory is in every BGP advertisement, these three attribute have to maintain, have to exist. Otherwise, BGP route communication will not happen. Okay, these three attribute must be exist. That's why this three attribute is called the well-known mandatory. Okay, that is keyword is mandatory, have to or must. Another one is well-known discretionary. Well-known discretionary, local preference and atomic aggregate. You can set local preference or atomic aggregate or not. This is optional. Okay, this is not mandatory option. In that case, you can say this two attribute is well-known discretionary. And another one is optional transitive. Optional transitive is a community attribute and aggregator. Community attribute and aggregator. To manipulate a BGP route, you can configure community and aggregator. This is transitive attribute. Last one, transitive means if you set any attribute, any value, you just set any community value in your own prefix or your customer prefix, this attribute will be, you will get this attribute through the internet route server. From the internet route server. Okay. In that case, this in that case, you can say it's a transitive. Okay. Non-transitive. Non-transitive is MED. cluster list and originator ID. That a cluster list and originator ID, this will happen or this will exist when you configure route reflector. Then you can see the cluster list and originator ID. Okay. Those three attribute is optional, non-transitive. Here MED means a multi-agent discriminator. AS means autonomous system. Okay. So this is the total attribute table. Total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 here. Okay. So PGP attribute. What is the purpose of PGP attribute? So first one, say here, BGP attributes are included in the update messages and describe the BGP prefixes received from API. Attributes are used to select the best one. Why we use attribute? Basically, attribute we use attribute, BGP attribute to select the best path. Okay, it can be for uh, inbound routes or it can be for outbound routes. Some attribute will use for inbound route manipulation and some attribute will use for outbound route manipulation. Okay, so see here, BGP attributes are included in the update message. Same thing, attributes are used to select the best path. Some common example like next hop, local preference, AS path, origin, MED, community. This is a common BGP attribute. All are used to select the best path. Okay. First one, BGP attribute. First one is next hop. First one is next hop. So when you configure the static routing, consider here. So this is internet and internet service provider, and this is a customer. You just configure here default static routing. Configure here default static routing. When you configure the default static routing, you have to mention the next hop. What will be the next? What will be the next hop? Okay, so next hop basically used for every routing protocol. IGP also use the next hop. If next hop is not reachable, those you will not get those prefixes. Okay, so next hop is a BGP attribute. This is the command to view the route, show route. In Juniper, you just put the command show route in operational mode. You will get all route details here. And hidden means if your route not installed in your route table, that will be multiple reason that have multiple reason. It can be filtered by policy. It can be PCP attribute mismatch or misconfiguration, or it can be next hop is not reachable. If next hop is not reachable, route will be in a hidden route table, not installed in global routing table. Okay, that's why here the command used here show route hidden CLI command to view the routes. Okay, next hop value is changed by default across eBGP links. That means when you get any route from just you receive route X from router 1. So from router 2, my next hop is this. If I send any prefix from router 2 to router 1, when we receive any prefix from router 1, on that prefix, next hop will be router 2 connected interface IP addresses. So ABGP automatically change the next hop value. But if you cause but in IBGP, next hop will not change automatically. Next hop change will not change automatically. So needs some policy to change the next hop. Okay. So this is the difference between EBGP and IBGP. So just summary. Next hop. ABGP automatically change the next hop. Number one. Number two, IBGP not change next hop value. Not change next hop value. Needs a policy. Okay. So this is the definition of next hop. Basically, BGP attribute next hop. Second, BGP attribute local preference. BGP attribute local preference. Local preference is which type of what is the type of attribute? What is the type? Local preference. This is basically optional, right? Right. This is basically optional. Well, not discretionary. This is not a mandatory attribute. Okay, but you can use local preference to select the best path. It's basically used for user upload traffic manipulation. If you want to manipulate user upload traffic, you have to use local preference. Okay. So determine the preferred path out of the AS. All BGP traffic in an AS flows toward the peer with the highest local preference. So you have if you have multiple service provider is connected with your router, so you just you want to select one service provider will be for upload traffic. One service provider will be for upload traffic. So user upload traffic. In that case, you can use local preference. But you have to maintain the policy. Under policy, you configure the local preference. Okay. Within the individual layers, nothing is sent across system. And this is not the transitive attribute. That means you configure or you set the local preference in your or for any prefix that will be that local preference value will be in your S that will not transit to another S. So in that case, this is not the transitive attribute. Okay. Local preference example. See here, this organization name is Minet. This is the AS number, and this organization is connected with two different ASN. So here is two router is connected. Router one sending traffic. Router one sending traffic. Also, router 1 have eBGP session between another AS. Router 2 have eBGP session between another AS. When I getting a route from this AS, I set the local preference is 100. This is basically default. When a route is coming from this AS, ISP A, and set the local preference is 300. So if just consider ISP is sending here default out. ISP is sending here default out. So I'm receiving the default route in router 1. I'm receiving the default route in router 2. Router 1 default route local preference is 300 and router 2 default route local preference is 100. So what is the higher value? 300 is the higher value. So router 1 sending this local preference value to router 2 and router 3 and all user upload traffic who is connected with router 2, router 3, and router 1. All user upload traffic will be traveled through ISP-A because of a higher local preference. And in a AS, local preference will transit. Okay. But I said here 300. So the default or local preference will be 300 in router 2. But when I am sending the default route to my customer, this local preference will not transit to my customer. The customer will get default local preference. In that case, you can say this is not the transitive attribute. When you change local preference in your AS router, if you change for any prefixes, this local preference will go to your iBGP session, but not go through the eBGP session. That's all. BGP attribute is AS path. Do you understand BGP attributes which I cover now? Any query from you? Is there any question? Nothing. Okay. Thank you. So third one is BGP attribute that is AS path. AS path, considering here, there is multiple AS is connected with each other. Route X is advertised from AS 501. This prefix advertised through a BGP coming here. Route is in 645. 645 also advertised the route X to 6452. 452 receiving the route X prefix and advertised to 521. So this is the route X origin AS is this one. In middle, this S is transit S for route X, and this is the destination S number. So this is basically the internet. Multiple AS is connected with each other. Okay. So consider here for route X, AS path is 645. That means 521, 452, 645, 501. That is the AS path. Here AS path length. Here AS path length is 3. Here AS path length is 3. If I consider another connectivity here, another connectivity, the AS path length here is the multiple AS number. So here is AS1, here is AS2, this AS3, and this is the AS4. The AS length is 4 here. So which one is shortest? This one is shortest. AS path length is 3. Basically, AS path is used to select the best route. Select the best route. Considering AS path length. Considering AS path length. If AS path length is smaller, that path will be the best path. Okay. So this is the main function of AS path. So if the AS number is in the path, it indicates that the route has been through the AS already. Used to indicate the path back to the route source and to prevent the routing loops already shared. Routes within the receiving route AS number in the AS path are considered loop, not advertised. AS path. See here the AS path for route X. For route X, when when I checking AS path from this router, I will get 645 and 501. Last one is the origin AS number. Last one is the origin AS number, and this is the transit AS number. All time, last one will be the own AS, prefix own AS. So this is all about AS path attribute in BGP. We use AS path attribute in BGP to manipulate the download traffic. When we will test lab, I will show you how to use AS path to manipulate the download traffic in lab section. Okay. So next BGP attribute is origin. This there is three multiple origin code here. One is I, another is E, and other is persimmon. IGP, EGP, and incomplete. There have some value 0, 1, 2. That means one route I'm getting, it's the router. Okay, BGP router. BGP router getting one prefix with origin I. Same prefix getting through this link, but origin code is E. Same prefix getting through eBGP, and the origin code is code symbol. So this is one is I, this one is E, and this one is code symbol. So which path will the best path? Which path will be the best path? So see here 0, 1, 2. So 0 is more preferred. 0 is greater than 1 is greater than 2. If 0 exists, that will be the best. That will be the best path. If 0 not exists, so 1 will be the best. So this is the origin code which use BGP attribute. Okay. Next, BGP attribute multi-exit discriminator, that is MED. Basically, you can use MED to manipulate upload and download traffic both. Upload and download traffic both. If you have multiple connection, you can say primary and secondary connection with single ISP, multiple connection with single ISP. If just you want to make primary link, secondary link, tertiary link. Okay, if primary link is down, traffic will goes in secondary link automatically. In that case, you can configure MED for both traffic, upload and download traffic. Okay, if you have multiple ISP, you are just customer, you are connected with multiple ISP. In that case, MED will not work. Okay, MED will not work. MED only connected is receiving the connected is, but this is will not advertise MED value to other service provider. So MED is not the transitive attribute. MED is not the transitive attribute. So in that case, if your connection is with single service provider and there is multiple link, if you want to make a primary, secondary, tertiary link, you can configure MED for upload and download traffic. Otherwise, not. And MED lower values will be the better, or best part will be the best part. You have to configure policy. Under policy, you have to mention the MED value. Lower value will be the preferred path or best path. It can be for upload traffic, it can be for download traffic. So next, very interesting BGP attribute is community. And this attribute is basically robust. You can set community value to take advantage from our regular work. Okay, you just consider you have multiple app stream and you have multiple customer. Okay, you have to maintain you have to configure the BGP with the customer and the app stream, and have to maintain the route advertisement in your organization. Okay, so when you receiving prefix from customer, you have to make sure which app stream will be for this customer, which app stream will be for this customer. Normally, we'll not set all app stream because of all app stream have not sufficient bandwidth. It may be okay, or you have to manually maintain something. In that case, if you maintain community-based routing, if you maintain the community-based routing, so BGP community is the best option. I think it reduces our regular work, and it is basically easy to troubleshoot to set the community, and you can set some community value for some specific services to adding uh, or rejecting routes. So there is multiple applied options. So I will show you community BGP community attribute in our lab section. So that will be better understanding of BGP attribute community. So you can set community attribute. Basically, you set the community value in route. Okay. You can set the community value. You can delete. You can add. There is multiple options. Okay. Select the active BGP route. How to select the active BGP route? So once BGP verifies next of reachability and that no loops exist, it select the active route. Normally, just you configure the BGP, next of is reachable. So you will get prefix. You will get prefix from BGP neighbor. Okay. And this prefix will be installed in your route table. If IPv4, prefix will be installed inet.0. If IPv6, route will be installed in inet6.0. Okay. If loop is detected, another option, loop is detected, route is not evaluated through the BGP route selection process. When a BGP route is installed in the routing table, it goes through a path selection process. So if one BGP route is installed in route table, if there is multiple path, if there is multiple path, you will get some prefixes in your router. BGP will calculate which path will be the best, considering BGP attribute. Considering BGP attribute. So we have to know the BGP attribute, and we already discussed regarding BGP attribute, but what is the way of selecting active route? What is the way? What is the algorithm? Okay, for path selection process. For BGP route or path selection process, BGP use this 9 step to select the best path. Okay, so consider here number one. Number one is prefer the highest local preference value. This is your router. You will get the default route from service provider 1 and service provider 2, and you set the local preference value uh, more than default, which route is getting through service provider 1. So this is the highest local preference value. When any route is getting from service provider 1, that path will be the best path. So highest local preference value will be the preferred. Number 2, prefer the shortest AS path. Prefer the shortest AS path length. Consider here, you will get, this is considering a router. So consider here another router. One prefix is connected here. One prefix is connected here. So it can be 1.1.1.0/24. I'm getting this prefix through ISP1, also in ISP2. So in AS path length, this is 1 and this is 2. AS path length is 2. If I choose through ISP1, AS path length will be 1, 2, and 3. So through ISP1, the AS path length is 3. Through ISP2, AS path length is 2. So which one is shortest? Through ISP2. This path is shortest. If local preference not set, in this router, automatically the lower AS path length will be the best path. Lower AS path length will be the best path. Is the number 2. Number 3, prefer the lowest origin value. Lowest origin value. Just consider here, if this is your router, you send some prefixes, same single prefix through service provider 1, and this is service provider 2, and this is the basically internet. Okay, it's basically internet. So you sending your prefix through service provider 1, the origin code is I, and you're sending your prefix through service provider 2, and origin code is question mark. So you advertise through ISP1, you advertise same prefixes through ISP2. This router receive the prefixes with origin code I and origin code question mark. So which one will be the best? I. That means you will get download traffic through ISP1, not the ISP2. So this is the origin code. Lowest origin code will be the preferred option. Next, 4, prefer the lowest MED value. MED value. So it's your router, and this is the service provider. This is the multiple connection here. This is the primary connection, and this is the secondary connection. You want to make this connection is primary and this connection is secondary. So simply set the primary connection MED value is lower and secondary connection MED value will be the higher. So lowest MED value will be preferred option. Number 5, prefer routes learned from an eBGP peer over an iBGP peer. So if consider here, you have two router. This is iBGP session. This is one AS, single AS. You can say is number, you can say is number 10. In AS10, there is two router 1 and router 2. And route between two router, there is IBGP session. Okay. Just consider here one customer is connected from here. Customer advertise prefixes. Customer advertise prefixes in this neighbor. This router receives this prefix. This customer also connected with this router. Connected with this router. So similarly, this customer, consider here, this is the primary and this is the secondary. So consider here, there is multiple POP. You can consider multiple POP. So customer advertise this prefix as a primary and advertise this prefix as a secondary. When this router receives prefix, getting prefix through eBGP, and from router 1 getting prefix through IBGP. So eBGP from getting routes through eBGP peer, that route will be the preferred for this router 2. Okay. Consider here, router 2 is connected upstream 1. So customer download traffic will be like this. If router 1 have also connectivity with upstream 1, so what happened? IBGP router 1 will get same routes through IBGP, also get route through the secondary path. So if customer not maintain the primary and secondary, not maintain the primary path and secondary path, BGP automatically select this router loopback IP address. This is the next section. BGP will choose another option. So in that case, in this scenario, these rules will not solve the solution. Will not get any solution from this. Okay. So in that case, BGP will choose this section. Go to this section. For eBGP receive route, prefer the current active route. Otherwise, prefer route from the pair with the lowest router ID. These two router ID will be different. Router ID will be different. If router 1 have lowest router ID, this will be the primary path. If router 2 is a lowest router ID, router 2 will be the primary path. Okay. So this is the clear concept of section 5. After section 5, prefer best exit from S. This is basically for IBGP. I also discussed, already discussed this section 7. 8. Prefer path with the shortest cluster length. If route reflector is configured in your network, lowest cluster ID will be the preferred. Okay. I will discuss it later in that section. Prefer routes from the peer with the lowest peer ID. That means you just connect with a single service provider. There is multiple link, primary and secondary. You just configure here. For this link, you configure 1.0/30. And for this link, you configure 1.4/30. So which one is lowest? In service provider in IP configured is 1.1 and customer in IP configured is 1.2. In secondary link, a service provider in IP configured is 1.5 and customer in IP configured is 1.6. So see here the lowest PRID. Which one is lowest? This one is the lowest. So in that case, automatically this path will be the primary path. This path will be the primary path. No need any, no need to set any BGP attribute to make primary and secondary path. Automatically, it will set primary and secondary path. So, what time is that? 6. Okay. So, selecting the active BGP route, path selection process, part 1. So, for each IBGPPR, install a physical next hop based on the 3 rules. What is the rule? BGP examines both the inet.0 and inet.3 routing tables for the BGP next hop value. Use the inet.3 version of the next hop through MPLS label switch path. If MPLS is configured, check inet.3 routing table. If only unicast, you configure only IPv for unicast, so no need to check MPLS or inet.3 table. If the preference value in the inet.0 and inet.3 routing tables tie, the physical next hop of the instance is inet.3. If your topology configured BGP and MPLS, there is multi-protocol BGP is there. There is multiple table inet.0 and inet.3. So if the same preference route have same preference in inet.0 and inet.3, inet.3 will be the best option. The number of equal cost path of each instance are examined. Equal cost path. Tie outputs when the traffic engineer BGP IGP knob is used for MPLS. Basically, it's a MPLS-T option. If MPLS-T option is MPLS-T option is configured, then you can send traffic. You can use multiple path basically. Otherwise, not. This is the BGP route selection summary. Same thing basically. Okay. So that's all. It's a BGP fundamental slide. So in our next class, I will discuss how to deploy the BGP. Okay, it can be eBGP, it can be iBGP, and check BGP attribute, how to configure the BGP attribute, how to check, how to troubleshoot. Okay, so if you have any question regarding today's class, you can ask any question. No. Okay. ঠিক আছে। So আল্লাহ হাফেজ। আসসালামু আলাইকুম।